Welcome to Lesson 1 on Exponent Laws. So, Lesson 1, Exponent Laws, Part 1. Exponents are a common occurrence in STEM mathematics. While many everyday tasks may occasionally involve exponents, it is most often relegated to only squares and cubes. In Pre-Calculus 11, we are not so lucky, as many of the exponents that we encounter may vary beyond squares and cubes, oftentimes involving negative numbers and fractions or decimals. Additionally, this variety of exponents can appear repeatedly within an expression or equation to further complicate matters. As such, it is to our benefit that we can simplify these exponents to make more complicated expressions and equations easier to solve or understand, provided that exponents have the same base, relationships exist that allow us to add, subtract, multiply, and divide themselves. So here we have this entire thing is called a power. Okay, it is the combination of the coefficient base and exponent. Yup. This is the entire thing is called a power. This entire thing is called a power. Let's move on. Here, the blue A. This is called the coefficient. All right. This is the number that multiplies the base after it has been multiplied by itself n times. If no coefficient is visible, it is equal to 1. All right, remember that the number in front of the base and exponent is called the coefficient. Here, the x, or also the variable, or whatever you call it, it is the base. The number to which, let's scroll a bit here, the exponent is attached. As you can see here, the exponent is attached to the base. The base is multiplied by itself n times. All right, so this is the base. And we have the little n thing here. This is called the exponent, you guessed it. It can be any real number. It can be a positive, negative, fractional, etc. All right, so this is the power. This is a power. This is the anatomy of a power. We scroll down here. We have exponent laws, all right? So the first of the exponent laws is the product law, which is just adding exponents, all right? So here we have an example of x to the power of n times x to the power of m is equal to x to the power of n plus m. The description reads, 2 or more powers can be simplified by adding their exponents together, provided that 1. They have the same base, 2. The powers are being multiplied together, and if these requirements are met, then the exponents are simply added together. So here are some examples. First example, y to the power of 4 multiplied by y to the power of 2. Let me do this one real quick. Oh my god, this looks so terrible. Is equal to, so you see here, they have the same base. The base here, which is the x here, in this case is a y, right? So the base here is y, and both of their bases are y. And so they're being multiplied by each other. Now we'll just add their exponents. So 4 plus 2, which is the same thing as y to the power of 6. Okay, so this is the answer. Next one. This one. So they all have the same base again right here, right? The base is a here. So whoops. And they're being multiplied by each other. So we just apply the product law. We add the exponents together. So this is equal to a to the power of 5 plus 9 plus negative 1. Or it can be written as subtracting 1, but this way is more clear, which is equal to a to the power 5 plus 9, 14, 14 minus 1, 13, a to the power 13. This is the answer. And then the next one, we have 3c multiplied by c to the power of 6. Here, this is the same thing as 3 times c to the power of 6. We see here, what we can simplify, the exponents, the c here. The c is here, actually. This is the same thing as 3c to the power of, we have, there's no exponent here, so we just know it's 1 here. So we just 1 plus 6, which is equal to 3 to the power of, 3 times c to the power of 7. All right, much better. And the last one. See if you can do this. Pause the video and see if you can do this using the product law. All right, if you have finished, let's do this. Let's check your answer now. 4d to the power of 7 times negative 3 times d. Now remember, this is multiplication. It doesn't matter the order of the order in which things are multiplied. So I'll just bring this 3 to the front, negative 3 to the front here, and multiply that first. Negative 12 d to the power of 7 times d, all right? It's the same thing as negative 12 d to the power of 8 here. All right. This is the product law. Now moving on. Here, next one is the quotient law. It's just subtracting exponents, all right? Here we have the example of x to the power of n divided by x to the power of m. This is the same thing as x to the power of n minus m. Let's read the description. 2 or more exponents can be simplified by subtracting their exponents together, provided that 1. They have the same base, 2. They are being divided by each other, and if these requirements are met, then the exponents are simply subtracted from one another. Let's check out these examples. First one, d to the power of 5 divided by d to the power of 3. Now, if we look up here, look at the quotient law, we see they have the same base, and they are being divided by each other. So therefore, we can apply the law, right? So this, whoops. Oh, I think I selected something. Okay, interesting. Okay, so this is the same thing as d to the power of 5, sorry, that looks terrible, 5 minus 3, right? Oh my god, that looks terrible too. This is the same thing as d to the power of 2, or you could just call it d squared, all right? Next one, x to the power of 11 over x to the power of 4, or you can also say it as x to the power of 11 divided by x to the power of 4. Here, apply the quotient law. X to the power of 11 minus 4, same thing as x to the power of 7. Now if we look at this, 13z cubed over, or divide by 2z. Okay, so remember, like the last time, it doesn't matter which order we divide them by. So if we do 13 over 2, and then we do z to the power 3 over z, or we do z to the power 3 over z, and then 13 over 2, doesn't really matter. In this case, I'm just going to do it in the order it's written in. I'll do 13 over 2 multiplied by z to the power of 3 over z. Now, 13 over 2 can technically be rewritten as 7.5, but in Pre-Calc 11, we like to write fractions as fractions, not decimals, because they're more precise and more accurate. So in this case, it would just be 13 over 2. Now, z to the power of 3 over z, this is the same thing as z to the power of 3 divided by z to the power of 1. So it's just z to the power of 3 minus 1, which is z to the power of 2. And the last one, pause the video and see if you can do this question using the quotient law. All right, if you have figured out the answer, and let's continue. Let's compare the answers. So here we see that the bottom, there's no coefficient. So we assume that's a 1 there. And so we do, in order it's divided by, in 3 over 1 is just 1. Sorry, 3 over 1 is just 3. Oh my god, I'm tripping today. And then we do the next one. N to the power of 2 over m to the power of 3, which is the same thing as m to the power of 2 minus 3, which is m to the power of negative 1. So the answer is 3 times n to the power of negative 1. All right, this is the quotient law. Moving on to power of a power law. It's just multiplying exponents. In the example, we have x to the power of n to the power of m, which is the same thing as x to the power of n times n. In the description, it reads, 2 or more exponents can be simplified by multiplying each other, provided that 1. There is a power contained in brackets. 2. There is an exponent on the bracket. If these requirements are met, then the exponents will multiply each other. Let's look at the first example. If we look according to the power law here, power of a power law here, we see that the n in this case is a 3, the m in this case is a 2. And if we look at here, x to the power of n times n, therefore, this is equal to x to the power of 3 times 2, which is just equal to x to the power of 6. Easy, eh? Now, if we look at this one, in this case, we multiply the 4 and the 7, right? So this is the same thing as e to the power of 7 times 4. Same thing as e to the power of 28. Well, I nearly wrote 24 there. Next one. 8 cubed to the power of 1 over 3. Same thing as 8 to the power of 3 times 1 over 3. If you don't, in this case, multiplying by a fraction, 3 over 1 times 1 over 3 is just 3 over 3, which is 1. 8 to the power of 1. Or it can also be written as a. Here we have this one. Pause the video and see if you can figure this out using the power of a power law. Alright, if you have finished solving the problem, we will move on. Compare your answer to mine. This entire thing, this entire monster, c to the power of 2 to the power of 3 to the power of 4. It's the same thing as c to the power of 2 times 3 times 4. Looks pretty menacing, but actually it's really not that hard. C to the power of 2 times 3 times 4, 2 times 3, 6, 6 times 4, 24. C to the power of 24. Alright. Now, ultimately, expressions and equations will become more complicated and will often involve applying multiple laws to simplify. Additionally, there are more exponent laws that we will add to our repertoire in the upcoming days. For now, we will focus on the first 3 laws shown above. So today we have covered the product law, the quotient law, and the power of a power law. We will use these here. For the first question, a to the power of 2 times a to the power of 3 over a to the power of 4. How do we go about solving this? If we look at the top, we see we can already simplify this using the product law, right? We can simplify the top using the product law. The bottom, we can't really simplify anything yet. So we will just start with simplifying the top. So a to the power of 2 times a to the power of 3 is the same thing as a to the power of 2 plus 3. Remember? Oh my god. Over a to the power of 4. Which is the same thing as a to the power of 5 over a to the power of 4. Now, we apply the quotient law to simplify this. Okay, so this is the same thing as a to the power of 5 minus 4, which is the same thing as a to the power of 1, or just a. Next one, x to the power of 6 over x to the power of 7 times x to the power of 3. Now, if we look at the top, the numerator here, we see that we can't really simplify anything. There's only x to the power of 6 there. If we look at the bottom, we see we can apply the product law there to simplify the denominator. All right, so let's do that first. We'll keep the top, x to the power of 6, over x to the power of 7 times x to the power of 3. In this case, we apply the product law. This is the same thing as x to the power of 7 plus 3. Okay. Now, this is equal to x to the power of 6 over x to the power of 10. Now we can apply the quotient law again. So we see the quotient law is x to the power, okay, so here we have x to the power of 6 divided by x to the power of 10. In the quotient law, we just subtract the exponents, right? So this case, this is x to the power of 6 minus 10. This is the same thing as x to the power of negative 4. We have a negative exponent. Now, here we have the last one. Pause the video and see if you can figure this out. Okay, we will continue here. Compare your answer to mine. So, how do I go about solving this? Well, if we look at the top, we see that there are two terms, two numbers. So, x to the power of 4 times y to the power of 10. Can we simplify this using the product law? No, we can't. Why? Because the product law specifically states that the bases have to be the same. In this case, this is different. The one base is x, one base is y. No, these bases are different. We cannot simplify the numerator any more than it already is. So then we look at the bottom. When we look at the bottom, it is y to the power of 2 to the power of 3. Ah, yes, we can simplify this. This is the power of a power law. So let's solve the bottom first. Let's simplify the bottom first. So x to the power of 4 times y to the power of 10 over y to the power of 2. If we apply the power of a power law, 2 times 3, right? Y to the power of 2 times 3, which is equal to x to the power of 4 times y to the power of 10 over y to the power of 6. Now, if we look about this, we can simplify this again. We see that we have a y variable at the top and a y variable at the bottom. They have the same base. They're both y's. So let's go about solving this again. Now we can apply the quotient law here. So we see that this is being divided by this quotient law. So this is the same thing as x to the power of 4 times y to the power of 10 minus 6. This is the same thing as x to the power of 4 times y to the power of 4. Alright, thank you for watching. I hope you learned something new today, and I'll see you in my next video.